Jörg, I guess you are with us, I hope.
Yes, I'm here. I'm here. I
Yeah,
was gone
now
for
Jörg
a
is on
short while.
vacation in Spain somewhere. So good to see you. And we
Yes, likewise.
told you.
So I'm from TEGnology, and we're working with thermal energy harvesting, and we're actually coming from the process area, so process monitoring and predictive maintenance, and also safety devices that we have driven by thermal energy harvesting. And but if you look into like the construction area, you actually find the same request. So here's like a statement from eBuilder, which I took from the internet, saying that the IoT or sensors in construction give you a lot of opportunities. That is like monitor site condition, which is the same for the industry, the process industry. Keep track of assets, very important part. Also in the logistics, maritime container tracking and stuff, which we also are involved in. Increase worker safety and improve facility management, all the things that we heard so far. So what we do is more or less that we replace, let's say, battery solutions. So we are in the low power area by energy by harvesting energy from a temperature difference, and we found some market feedback there. First of all, that there's a huge number of batteries going to be changed already in a couple of years, which has a sustainable aspect, of course, but that also has some cost. Replacing a battery in a smart building, we got told, is like €100 per sensor unit, and that is not the battery, but that is the person going out there, the logistics related to planning all these changes. When you go to the industrial installations, you're getting even higher, and if you have to stop a process, for instance, to change a battery, then you're really in a dark room there with more than 100,000 per day or per hour. It doesn't really make a difference then anymore. So there's definitely a need. But then also you have this issue with batteries or also cabling or other energy harvesting methods, that it's actually difficult in harsh environment, like very hot, very cold, very chemical, for instance. And of course, you have the green agenda that prohibits the use of batteries in many cases. But for building industry, I think the most striking thing is how to change a battery that is actually built into something, like in a wall or in an insulation layer, in a roof, and so on. So you cannot change that. And then I think it was interesting to hear that we have to expand this monitoring aspect for buildings, like to the lifetime level. So if you want to monitor a building for 25 years or something, or even longer, then you will definitely not make it with a battery-driven device. So here we suggest energy harvesting, thermal energy harvesting. We have a hot side, we have a cold side, and inside we have some material that is actually giving a voltage and power, generating a power, the Peltier element, kind of Seebeck effect also called. And by adding some electronics to it, you get a regulated voltage power supply out of it. So we are not doing IoT or IIoT, but we are more or less enabling IoT or IIoT. And what you get then when you have this power supply, that you have a functional device that at high temperatures, at very low temperatures, -20, -30 degrees, it's completely not affected by humidity, dirt, or G-forces, vibrations, or anything, because it's just solid state physics. So there's no moving parts, no chemistry involved. Of course, it works also at darkness compared to solar cells, for instance. And the game changer is that you suddenly no longer have to go on compromise for the battery lifetime, right? The battery-driven solutions, they last 15 years, but then you like only allowed to measure once a day or something like that. Depends, of course, on the sensor. That's why I ask what sensor, what the power consumption was for the other sensor we heard of today. Yes, and it enables, of course, that you build the sensor completely into the building, and I come with some examples later on. Compared to cabling, minimum planning cost and installation cost, you just put it there and it stays there like a battery. But compared to the battery, you don't have like cost of ownership, because you simply leave it there until the end of the lifetime of maybe the sensor, maybe the building, whatever gives up first. And here comes some example, because we only have 10 minutes. This is an example from the iClimabuild project. That's a EU project for new materials and buildings. And there was developed a concrete foam that is insulating. So they build up a wall segment that you can see here of a very stiff concrete. Then you have a concrete foam working as an insulation layer, and you have another stiff layer making up a solid element, like a building element that you can put into the wall. In this case here, you have a window up here, and then you have wall segments down here. And we built into this wall segment an energy harvester, harvesting the energy difference between the outside of the building and the inside of the building, and powering with this difference. We were powering a humidity sensor and the temperature sensor inside the insulation layer. And down here you can see the results. These red dots here are the red lines. Those are measurement events. And the blue line is the delta T that we have between the inside and outside. And as you can see here, it's a little, there's a little offset in between, but it stops working or sending data at around 5 degrees difference in temperature from outside to inside. And it starts again somewhere here. So with the offset at around 5 degrees difference. At 5 degrees temperature difference, you get data every 20 minutes. And that is like wireless data with a LoRaWAN network. So you read out the sensor, you send the data, and then you recharge the internal supercap for 20 minutes before you can again send data. And the higher the temperature difference is, and you can see here very nicely that you have sun shining or cloudy. So when there's a cloud, it's going down. When there's sun, it's getting up. There you have quite high delta T, actually above 10 degrees usually, where you get a lot of data points. So we could design it actually much smaller than in this case here. This is a very over-engineered example. It's like 4 times 4 centimeters. I think we could bring it down to 1 times 1 centimeter easily and still have like several measurement points during a day, measuring the humidity and insulation layer. Well, and the value, of course, is that you that way could detect leakage or building failures, because if you have a wet insulation layer, it's of course no longer insulating. So that actually has a value, and it's not only academic exercise. Another example, which is actually an academic exercise, more or less just to show what you can, what thermal sources you have actually on your house, is that we built, or we put our SenseEver Alpha. This is here the energy harvester. We just stick it to the outside wall of our office, harvesting more or less the temperature of the outside wall when sun is shining onto it, compared to the outside air. And that again is the interesting part. Of course, during sunshine, you have, of course, a hotter surface, but when it's raining, for instance, and the wind is blowing, you also get a colder surface. So you almost always have a delta T of whatever 5-6 degrees on the building itself. On the other hand, you can also build it, of course, again into the building, below the roof, black roof ceilings. You can put it into asphalt that is getting hot compared to the soil temperature below it. And I looked it up. You can actually even drill a hole into a tree, because the tree also have some things going on in there that's generating temperature. So also there you will get like a couple of degrees temperature difference to the surrounding air of the tree. So you could harvest the tree to power a sensor. So those examples show that we have like specialized on the low degree delta T temperature difference. We don't need 60, 80, 100 degrees Celsius temperature difference. We can live with a couple of centigrades. Another example here from Alfa Laval. We are located here in Denmark, actually, at the Alfa Laval Innovation House. They do heat exchangers, among others. This is, of course, a very nice example, because there we have like a heat when the thing is running. There is a heat difference of 40 degrees. So that is a luxury, a lot of delta T. And we could enable their sensor system here, monitoring pressure and temperature, which usually has a battery lifetime of 2 years, measuring every 15 minutes. We could change that to like lifetime, lifetime, device lifetime, power lifetime, and even increasing the measurement points by factor 10. So they can measure now every 1.5 minutes instead of every 15 minutes. That shows nicely, again, you don't have to go and compromise anymore, because you simply recharge your device continuously. Another interesting almost construction, but very close actually, is district heating, of course. There you also have the wish to have to move myself here, right? You can see here again the Sense Ever Alpha. It's called our power supply connected to the inlet, which usually is like 60 degrees, but this is only a control pipe, so this is like sticking out of the ground and it has only like 40 degrees. The whole area is heating up to about 30 degrees, but it's still sending very nicely the data. And in this case, the data is the pressure measured by this ABB sensor. That is an ABB standard pressure sensor, and a temperature sensor here connected to the inlet. And the whole thing is connected with a TEGo LoRaWAN sensor gateways, so to say. Well, it's sending the data via LoRaWAN that it is collecting from the ABB sensor and the temperature sensor. The solution before was driven by a car battery. You can see it here, like in the corner, in the right corner. They had to change it every 6 months because it's also decharging itself over time. So this was a very big release for them because they don't have to go there anymore to change the battery and still get the data continuously. Yeah, what our customers' motivation is actually is not only that you can put it into a harsh environment or something like installing it where it's very hot or very cold, but there are also other aspects when you use energy harvesting in general as well. For instance, if you want to ATEX certify your product, where you have the battery installed, ATEX is for explosive environment. Then you have to certify it in a different way, a more expensive way, because you have the whole lifetime energy on your device. When you have an energy harvester, you only have the minimum amount of energy available, so you don't have to. You're not in such a high ATEX category to get it certified. So it's actually cheaper to certify it. There's also an issue with sensors that are, in some cases, they are not connected to the server, or there's a server outage. When they try to reconnect, they use a lot of energy, and they also go into a mode where they suddenly only reconnect every day because they want to save the battery. When you have a harvester, you don't have that issue. You simply recharge your internal battery, and then you try to reconnect again. Yeah, also that happened to some of the people that we talked to, that they simply had to exchange sensors in the field because they made a software update that was faulty, and that faulty software update was draining the battery. Again, the same issue you don't have with recharging batteries powered by an energy harvester. And then also the trend goes to this bidirectional communication with sensors, that you want to update your sensor, which is usually rather battery consuming. And that's also playing in our hands actually, that this trend is going on. So yeah, but because of course we can refresh the battery continuously. That said, you don't have to replace the battery, of course, with the technology, but you can also simply increase the battery lifetime that you combine by combining a battery and its thermal energy harvester. So the battery heavy parts are taken from the harvester, and then when the delta T is not available, for instance, then the battery could take over.
Great.
That's it.
Great. Thank you so much, Jörg. So let's see if we have a question quickly from somebody. I don't see any. So there's one. Is there a linear decrease in power output when the harvester size is decreased?
No.
Quick question.
Yeah.
Okay. So I think we stop there, Jörg. It's always a pleasure to be with you and listen to what you do with your spectacular technology. And to the audience, thank you so much for having been with us. I'm happy and proud to present 4 of my favorite companies today. It's just so refreshing and interesting to follow those fantastic technologies that we bring forward from companies around the world, actually. So I hope you enjoyed. We're going to send you an email afterwards with what we call a post-event email with contact data and all of that. And if you, for some reason, would like to get into touch or don't get hold of people, you can always contact me if you like. So having said all of that, and also we're gonna publish, of course, the presentations on our YouTube channel a little bit later, and we're gonna ping you about that as well. So with all of that, thank you so much. Have a good remaining time of the day, especially you, Jörg, in Spain. Bye-bye. Thank you.